Hello everyone. In this video I'm going to explain how we design a sequence detector in digital circuits using flip-flops or JK flip-flops or whatever, any kind of flip-flops. I will use an example to explain this, and I'm going to use a Mealy machine to do this design. Now the difference between Mealy machines and Moore machines is not in the scope of this video, but I will just explain the particularity of the Mealy machine when I'm using it. So let us, again, as I said, we're going to use an example. So let us use an example of a sequence detector for 10110. So to remind you, this means that I have a logical circuit, a Boolean circuit that has an input. This input is a sequence of bits, ones and zeros, and it will actually get its output to be a 1 once I have this sequence on the input. So if I receive a 1 and then a 0 and then a 1 and then a 1 and then a 0, the output will be 1 for one cycle, and then it will get back to 0, waiting for the next sequence, the next occurrence of the sequence. So this is the sequence detector, and in order to be able to design this circuit, we want, actually, again, systematically, the systematic steps to do a design of a sequential circuit. We start by the state diagram. So to remind you, design means you state by the state diagram, you end by the circuit diagram. The analysis is the opposite. You have the circuit diagram and you want to get to the state diagram. So in order to work with this, what we want to do is to start by drawing the state diagram. And the state diagram for this sequence detector, we start by the initial state, which is the opposite of the first bit that I want to receive. So the first bit in my sequence. So I will start by a state. I will call it 0, because I'm receiving zeros here, and as long as I'm receiving zeros, I will state in this state, the same state. I haven't moved to any state. I will move to the state 1 once I receive the first one. So I will stay in the state 0, and the output is 0, and this is what makes this a Mealy machine, because I have this output here. The output is actually a combinational output, and it's not a state itself. Now the system will stay in this 0 state as long as I receive zeros, and it will move to a new state, which is 1, when I receive a 1, but the output will stay 0 in this case. So the system will stay, the circuit or the system will stay in the state 1 as long as I'm receiving a 1, and this output is 0. So again, when I'm in a state, I have two options, either 0 or 1, right? So these are the two possibilities that I have. So I will stay in the state 0 because I can have a sequence of 1, 1, 1, 100 ones, and then I will start to have the 0. So in this case, I will have the 1, 0 from my sequence. So I will stay in the state 1 as long as I'm receiving ones until I receive a 0, and in this case, I will move to a new state, which is the state 1, 0. So this is when I have a 0 and the output is 0. Now 1, 0, I have two options, either a 0 or a 1. If I receive a 0, so this means that I have 1, 0, 0, the sequence has been broken. So actually I will return from this state to the initial state. So this is 0 and 0. But if I receive a 1, I have now the 1, 0, 1. So this moves me to a state which is 1, 0, 1. So this is 1 and the output is 0. Now from this new state, which is the 1, 0, 1, I have two options, either a 0. So I have 1, 0, 1 and then a 0. So 1 0 1 0, it broke my sequence, right? 1 0 1 0, but it will not return me to the initial state. It will return me to this state, right? Because now I still have the 1 0 from the sequence that I'm looking for. So this is a 0 0, and then from here also the other option is to have 1 0 1 1. 1 0 1 1 means I am moving closer to, excuse me, to the sequence that I am looking for. So this is a 1 0 and this is 1 0 1 1. Now from 1 0 1 1, if I receive a 0, now two things. This will return me to this state, right? But with an output of 1, because I now have the entire sequence I'm looking for. And if I receive a 1, so I have 1 0 1 1, this will actually 1 1 1, this will actually return me to this state. So this is a 1 0, right? So now this is the circuit for the actually this is the state diagram for this circuit. What I can do now is simply convert this this circuit into a circuit, this state diagram into a circuit. So the first thing I need to do is to code my states. So let me say this is 0, this is 1, this is 2, this is 3, and this is 4. And what I want to do now is simply use, like, draw the state table. So I have here 5 states, which means that I need 3 flip-flops. So I can have here Q2, Q1, and Q0. Okay, and then I have actually, this is the current state, and then I will have the next state. So again, Q2, so before the next state, actually I will have the input, right? So this input, I will call it, let me say, in, and I will have here Q2, Q1, Q0, and the output. So this output, let me call it out or O. And once this is done, once this is done, I will finish this, but I will not have enough space, and I will end the video by this. So actually 0 1 0 1 0 1 0 1, and I will have actually 16 different, so 0 1 0 1 and so on, and I will have here 0 0 1 1 0 0 1 1 0 0 and 1 1 and so on, and then 0 0 0 0 1 1 1 1 0 0 0 0 and 1 1 1 1, and then 8 zeros and 8 ones. So how I will do this table, actually, again, we can see here that I have 0 0 0, so this is 0. If the input is 0, I will have the next state will be 0 and the output is 0. This is what I see here, actually here, right? If the state is 0 and the input is 0, the next state will be 0 and the output is 0. If the input, if the current state, now this one, the current state is 0, the input is 1, so now I'm here, I will move to the 0 0 0 1, and then I will have the output is equal to 0, and so on, and I will continue filling this table. Once I fill this table, depending on the flip-flop that I'm using, I will find the values of the inputs of the flip-flop. So for example, if I have JK, then in this case I will find the J0 K0 according to the transfer table of of jk. So I will say, okay, I have here from like a transfer between 0 and 0. So 0 current state, next state is 0. So this is a 0x, okay, on 0 on j and x, okay, and so on. Once I'm done with this, what I'm going to do is actually to simplify the functions for j0, k0, j1, k1, j2, k2, and then draw the circuit. Hope this is helpful. Thank you very much.